Hello everyone and welcome to the 8th challenge on Damn Vulnerable DeFi. Let's go ahead and get right into it. So this one's called Puppet and we're actually utilizing a cool thing in DeFi called liquidity pools. So let's go ahead and get right into it. So there's a huge lending pool borrowing damn valuable tokens where you first need to deposit twice the borrow amount in ETH as collateral. The pool currently has 100,000 DVTs in liquidity. There's a DVT market opened in a Uniswap V1 exchange, currently with 10 ETH and 10 DVT in liquidity. Starting with 25 ETH and 1,000 DVTs in balance, you must steal all tokens from the lending pool. Now, to kind of understand what a liquidity pool is and how we're going to exploit it, I'm going to first explain kind of how it works, essentially. Now, this is going to be terrible explanation, so, bear with me. I do recommend that you kind of do your own research and kind of figure out what this is on your own, but I'll try kind of explain it in rudimentary terms as much as I can. So a liquidity pool is essentially a way for a token to be traded instantaneously without having to find to match a buyer and a seller. So usually if you want to trade, say, 100 ETH for 100 tokens, you need to make sure that there's a buyer and a seller that both want the same thing so that you can mix and match it. In a liquidity pool, which is powered by a smart contract, essentially what happens is, more often than not, you will have a pool that has half of the same, that's half of one token and half of another token. And when I mean half, I mean the total value of the reserve amount of the one token should equal the total value of the reserve amount of another token. So for example, if you had 50 DVT and 50 ETH and their one DVT equaled one ETH, that would be a correct liquidity pool, as in like the values are the same. If you had 1 ETH equals 10 DVT, then you would have, say, 100 ETH and then 1,000 DVT in that liquidity pool. And the idea behind it is that if the price changes between the two, it creates a profitable opportunity for arbitrageurs to, make use of that value difference, take it out and sell it on another exchange for a profit. And so that's how you get this kind of automated market maker of how that all kind of works. So I won't be going into too much detail of how this works. I hope that kind of explained it a little bit. I will show you how this works in this exploit. So let's have a look at this Puppet pool. So here's the challenge. We have a single Solidity file here, and let's have a look. So we have a mapping of an address. So we have some kind of deposits, so mapping your address to how much you've deposited. There's a Uniswap pair, which is an address. So that's going to be the liquidity pool that I was just speaking about. We have the token that we're speaking about as well. We have an event borrowed. In the constructor, we just set up that token and Uniswap pair. So then we have 3 functions here: borrow, calculate deposit required, and compute oracle price. So the idea of this challenge, or this contract, is that to borrow some tokens, you first need to deposit twice the amount of ETH, assuming that 1 DVT equals 1 ETH. So let's have a look and see how this works. So let's say I want to borrow 10 DVTs. It's first going to calculate the deposit required to be, we're going to go down here, and it's going to calculate, all right, compute the oracle price, and the oracle price is going to be what the price of the token is in Way according to the Uniswap pair, so you can see that down here. And this times 10 to the 18, this is just some decimal math stuff just to make sure that we don't lose any data in the operations. So firstly, what it's going to do to compute the oracle price is it's going to get the Uniswap pair balance and divide by the balance of the Uniswap pair. So what this means is it's going to get the ratio between the two reserves and see what the price is. So again, the idea is that the price should be the same of the two reserves. So the total of the two reserves should be the same. Therefore, if one is a lot higher than the other, they would still have the same value, but the ratio between the two is going to be different. And that's what this oracle price is trying to calculate. So then from here, it's going to do whatever the oracle price is, multiply it by the amount, and then it's going to multiply that by 2. So you need twice the amount of ETH to whatever the ratio is. Again, this times 10 to the to the 18. That's just counteracting this one. So yeah. Now, I will say here that I don't know if there is a way to exploit this using mathematical operations such as numeric overflows and underflows, because they're using unsafe operations here, because we can control this amount to whatever we want it to be. So I'm not sure if there's a way that you can actually exploit this, but I'm going to exploit it in a different way. If there is, please let me know. I'm very interested to see how you did it. But otherwise, we're going to go ahead with the other solution. Okay. So we now have the deposit required. Again, we want to borrow 10 tokens. That means we're going to have to deposit 20 ETH. So then the message.value is going to be greater than or equal to the deposit required. Then afterwards, it's just going to send that value to us if it's greater than. It will then, the deposit will then increase by how much we just deposited, and then it will transfer that token to us that we want to borrow. Cool. All right, so that's the borrow, and then we've also gone through these two as well. So how do we exploit this? And again, this is kind of coming back to how Uniswap V1 liquidity pools work. The way that we will be able to do this is by essentially creating a false value proposition between the two currencies. So at the moment, when we have a look, we can see that the initial token reserve for ETH and for DVT is at 10. So this is assuming that 1 DVT equals 1 Ethereum. Now, I'm going to copy some of my notes from when I wrote up this solution. So what will happen is here. When we deposit, when we trade within Uniswap, we need to put 1 token in and we get 1 token out. So if you've done kind of swapping in Uniswap, you would have seen this before. So let me make this a little bit nicer. Okay, so okay. Here's what's going to happen. Essentially, when I put my tokens in, I want to put in 1,000 DVT tokens. And so what this is going to do, it's going to set the amount in the reserve to be 1,010. And then it's going to, the ETH balance is not going to change because it's going to be on 10 ETH. And the important thing to note is that the calculation, as in the ratio between the two, is done after the deposit, but before the withdrawal. Okay? So once we put in our deposits, right? So initially it's going to be 10 ETH to 10 DVT. We're then going to put in 10 ETH to make it 1,010 DVT. And so what this does is it heavily devalues the DVT token. And I'll tell you why. Because now this is meant to be a 50-50 split of value. So if we have 1,000 DVT and 10 ETH, that is equivalating 1 ETH to equal 100 DVT or 101 DVT. So what we can do is we can essentially manipulate the market such that we can get a very, very good Oracle price for our DVT tokens. The way that this is calculated of how much ETH that you'll get back for a deposit of 1,000 DVT is like this. So we'll have the numerator being the deposited tokens multiplied by the ETH reserve. So I'm going to put in 10 ETH, 1,000 tokens, and we're going to multiply that by 10 ETH. So we can see that here. The denominator is then the total amount of tokens, right? Before the deposit, which is 10 again, plus the deposited amount of tokens, which is going to be 1,000. So what this does is it then calculates the output. So the output of that is going to be 9.9009 ETH, right? Which means that gives us a leftover amount of ETH in the reserve to be 0.09. Now, if you have 0.09 ETH and 1,010 DVT tokens, you have heavily devalued the DVT token, such that, you know, it's almost worth nothing. So one DVT is approximately equal to 0.09 divided by 1,010, which is a super small number, right? So this is how we're manipulating the market. Now, the only reason that we're able to do this is because we have orders of magnitude more value of that currency than what the current liquidity pool has. The liquidity pool only has 10 ETH and 10 DVT. We have 25 ETH and 1,000 DVT. So that's almost, you know, 2 orders of magnitude higher. Okay, so then the Oracle price will equate the borrowing of the entire lending pool's funds of 100,000 DVT for, right, like this. So we'll get 100,000 DVT. We want to borrow the whole thing because that's the whole point of the challenge is we need to steal all these tokens. And it's going to go, okay, so what's the current price of 1 DVT in ETH essentially, which is that 0.09 divided by 1,010. It's then going to multiply that by 100,000 because you want to do this 100,000 times and then multiply that by 2. Then just handily enough, that comes just under 20 ETH. So we have 25 ETH, so we can go ahead and straight up do that. So that's great. And so then after that will then, we'll request the loan from the lending pool to borrow all the DVT for 20 ETH, which leaves us with this amount. So the attacker, we have 25 ETH plus the 9.9 ETH that we got from depositing the 1,000 DVT, minus the deposit required, which is approximately 20 ETH to borrow the DVT. So it's around 25 plus around 10 gives us 35, minus the 20, which leaves us with around 15 ETH left. And we will have a total of approximately 100,000 DVT, not approximately, exactly. So then, So then to put the liquidity pool back to its original ratio, so we want to put it back to that, that 10 to 10 value or that 1 to 1 value, we can deposit enough ETH to then get the original 1,000 tokens back. And so that turns out to be around 10 Ethereum again. So this time we calculate the ratio post-withdrawal. So instead of saying we're going to deposit 1,000 1,000 tokens, we're going to say, I want to get 1,000 tokens back. How much ETH do I need to deposit? So let's copy this. So what we're going to do is, once we withdraw that 1,000 ETH, it's not going to have this calculation here, right? So 1 DVT is going to be approximately 0.009 ETH. So 1,000 DVT is going to approximately cost 9 ETH. Therefore, it's actually 9 point some number. There's some fees involved. So within the liquidity pool, every time you do a swap, there's a 0.3% cut that's taken away. So then we pay the remaining 10 ETH to retrieve 1,000 DVT, which returns the Uniswap pool back to 10 ETH and 10 DVT. So after this is all done, after this attack is done, we want to see what our kind of value proposition is after that. Where do we stand? So we finish our attack with approximately 5 ETH and 10 DVT in total value. The reason being is we had that 15 ETH. We had to pay 10 ETH again to put the liquidity pool back to its original ratio, and then we get our 1,000 ETH back. So I think this should actually be, so it's 100,000, should be around like that. And assuming the liquidity pool's initial value of 50/50 is correct, then the value has increased. So we have our initial value of 25 ETH plus 1,000 DVT, which is equal to ETH of around 1,025. And with a final value of 5, because we have 5 ETH left, plus 101,000, which leaves us with 101,005. So that's a huge increase, almost a 100x increase in our position. So very, very profitable for us. So now that I've explained the whole exploit and all this kind of stuff, and let's go ahead and actually code this and how we're going to exploit this. So let's go ahead and write this up. So down here, we're going to firstly connect to the contracts as the attacker, just so we have this. And then we're also going to create a little helper function that can log the attacker balances as we go through. So we can kind of see and follow our thought process as we come down here. So this is going to get the ETH balance and then the token balance and then print them out. So initially, we are going to print them out for the attacker and then the Uniswap address. So we should expect initially this should be 25 and 1,000 and this should be 10 and 10 because we haven't done any fancy stuff yet. So the next thing that we're going to need to do is set up for the approval. So to do a Uniswap token swap, you're going to need to approve Uniswap to spend your tokens on your behalf initially. So we're just going to have to approve that. Nothing too crazy. And then the next thing that we're going to do is calculate the ETH payout. So the ETH payout is going to be how much ETH we're going to get for the 1,000 DVT tokens that we're going to put in here. So we do this via a get token to ETH input price. Now, the way that I got this is through essentially the Uniswap docs. So the Uniswap docs here are really, really helpful. Uniswap is actually up to V3. So we need to be looking at the V1 documentation here. So we can go ahead and look up, I think it was like ETH to token. ETH to token, yeah, get ETH to token output price. There's a difference between the output and the input price. It's like essentially, do you want a fixed number of input tokens that you're going to provide, or do you want a fixed number of output tokens? So it's like, I'm going to put in 1,000, how much am I going to get back? Or is it, I want 1,000, how much do I have to put in here? So you can look this up and how you actually interact with that, and that's how you do that. So once we come back here, yeah. Okay, cool. So we're going to do get the token ETH input price, and we want to see how much ETH we will get if we put in the attacker's initial token balance, which is around 1,000 DVT. Now, the reason I'm putting the gas limit here is just because I ran into issues with gas limits. So I just increased the gas limit to very, very high. Okay, so then we can go ahead and log these results. Come on. So transferring of 1,000 tokens will net this amount ETH, and now we're going to transfer those tokens. So how do we do that? Again, using the Uniswap docs, we can go ahead and do a token to ETH swap input. So this is the exact amount of tokens that we want to transfer. We want a minimum of 9 ETH in return because we're expecting around a 9.9 return. And this deadline here is basically if this transaction doesn't get approved or processed before this deadline, then cancel or revert it. So if we come up here and actually, before we continue, have a look at how this was set up, right? So, we do all the deployments and everything, and we can see the interesting thing here is this Uniswap exchange factory and the Uniswap factory. And so this goes ahead and deploys it, and it's actually using the contract ABI in JSON form. And if you want to take a look at how that looks, you can just have a look at in the root directory. There's build Uniswap v1 JSON. You can see all this. And then where the functions are actually implemented, that's all in these fancy numbers here. So I don't know how to decode this. I'm not a robot, but I'm sure someone can. Cool. All right. So let's continue. So we've now just swapped the token for the ETH. And we want to now just quickly check, all right, what are the new balances? So we've just swapped it. We should expect the attacker to have 0 DVT and around 35 Ethereum. And in the Uniswap address, we should see that it should have around 0 Ethereum and approximately 1,010 in DVT, heavily devaluing the DVT. Okay, next one. So the next thing that we need to do is deposit all the ETH required to gain all the tokens from the pool. So remember, once we've done that calculation and we've heavily devalued the DVT, we then are able to borrow so much more because we've devalued the DVT token in relation to the ETH. So the first thing we want to do is calculate the deposit required to borrow the entire balance. We calculated this to become just under 20 Ethereum, and we'll see that when we actually run this. We then want the deposit required. We print it out, and we go ahead and borrow that with the deposit exactly that we have calculated. Then we log the attacker balances and see what happens. So at this point, since we borrowed that 100,000, we should have around 100,000 DVT, and we had 35 Ethereum minus 20, which is left with 15 Ethereum. So at this point, we could say that we've solved the challenge. However, I think the token balance to be greater than. Yeah, so at this point we could, but we can just go ahead and reset the liquidity pool back to its original position of 1-to-1 ratio, and that way we can get some extra tokens as well, and we can meet this greater than rather than greater than or equal to, because right now we haven't met all the success conditions. If I was to run yarn run puppet, we should see a failure. Yeah, so yeah. I think, anyway, we'll see. So we'll continue going along. And the next thing that we want to do is this set of things. Yeah. So what this is going to do is get the buyback address. So how much for our 1,000 DVT, how much in ETH do we need to pay? So to tokens to buy back is the initial balance. We then get the ETH to token output price. So we want to buy back 1,000. How much ETH do we need to pay? Again, I had to increase the gas limit here, and then we can print out how much is required. The next thing that we need to do is finally get those 1,000 tokens back by running an ETH to token swap output. Again, output is like we want 1,000 out, as opposed to the token to ETH swap input. It's like we want 1,000 to come in. Okay, yep. So then we have that. We have, same thing, how much we want to buy back, what's the deadline for this, and how much we're going to send with the request, and also we're updating the gas limit as well. And that's it. Afterwards, we can just go ahead and log all the balances and see where we ended up. So let's go ahead and run this, and hopefully this works. I wasn't expecting that. Okay, yeah. So we go ahead and we can see that that is working now. So let's just follow the flow here. So the initial balance of the attacker is 25 to 1,000, and the initial balance of Uniswap is 1010. Approving the balance, a transfer of 1,000 tokens is going to net 9.9, this amount here. Now, it's really important to note here that there is a 0.3% cut, as I've been mentioning, and I didn't actually include that in the calculations in the comments above. But yeah, so that's important to take note, and that's why it's not a perfect 10 Ethereum, essentially. And also because it's not a perfect 100% ratio. We then transfer the tokens for ETH, so we then have nearly 35 ETH, and then the token balance of the attacker, because we deposited the 1,000, is now 0. Similarly, the Uniswap address now has a ratio of 0.099 to 1,010. So we then calculate what the deposit required is to borrow the 100,000 DVT tokens. It comes out to be just under 20 Ethereum, and we have that 20 Ethereum. So we go ahead and do the swap, do the borrow. So we put in that 20 Ethereum. We then only have 15 Ethereum, and we have the 100,000 DVT. So then the ETH required for 1,000 tokens, which is not formatted correctly, is again another 9.9 ETH. So then we see the finished balance of the attacker to be 5 ETH and 101,000. And the balance of the lender is 19 ETH and 0 DVT. And the balance of Uniswap will then be 10, point a little bit, and 10 DVT. And that's how you solve this challenge. Hopefully you understood that. The concept of liquidity pools are pretty difficult to understand. Some recommended YouTube channels that you should check out if you want to really learn the mechanics behind how they work. There's Finematics, and yeah, I think that's the one that has a really, really awesome video. I'll chuck the link in the description below. And yeah, so again, hope you learned something. It was a lot of fun teaching this, and I will see you in the next one where we tackle the same challenge essentially, but in Uniswap v2. And I will catch you later.